This video is on how to write products given reactants. Make sure you've already watched the types of reaction videos and the balancing videos so that you know how to do those, because now we're just going to be applying it all. So some steps to help you write the products. First thing is going to be to write reactant formulas if they're not given, because that will help you do step number 2, which would be to determine the type of reaction. So it's really helpful to have your formulas for your reactants to help you then figure out the type, and I'll give you some tips for that in a second. Once you've figured out the type, then you're going to want to write the products. So based on the type, that's going to be how you determine how to write the products. For instance, if it's synthesis, you're going to combine them to write the products. If it's decomposition, it's going to break apart, and so on. The last thing you want to do is you want to balance your reaction. If your reaction won't balance, like it's impossible, you have one or more formulas that are wrong. So be very aware of that. It's really, really important that you get your formulas for your products and your reactants correct. So some things to look for to determine the type. If it's synthesis, you're typically going to see an element plus another element as your reactants. So it's going to be like A plus O2, Fe plus O2, something like that. For decomposition, to recognize it, you're going to have just one reactant. So it's going to be some compound that's going to break apart. So one reactant, and that's it. That's how you know it's decomposition. If it's single replacement, you're going to have an element plus a compound, because that element then is going to come replace something in that compound. Remember, it's going to switch out of one of the elements. Double replacement is when you're going to have a compound plus a compound. That's when they switch partners. And then if it's combustion, you're going to have some sort of fuel. And we talked about in the last video, a fuel could be like a hydrocarbon or an alcohol. So something with CNH or something with CH and OH, and it's always going to be plus O2. Okay? So the one that gets confused, the two that get confused for each other are single replacement and combustion. Because combustion looks like it's single replacement in that you have an element, so you have oxygen, plus a compound. So be careful. Every time you have that single element in the compound, is the element oxygen? If it is, look, do you have a fuel? Do you have a hydrocarbon and an alcohol? If so, it's combustion. If not, then it's single replacement. So let's do some examples. So first one, I've got C2H6 plus oxygen. So I'm going to write my formulas first. Well, I was given one. Well, that's nice. C2H6 plus oxygen is diatomic, so it's O2. So looking at this, it looks like it's an element and a compound. So check, is it combustion before I assume it's single replacement? Well, yeah, it's combustion. I have oxygen, and I have a fuel, a hydrocarbon, carbon and hydrogen. So this is combustion. And in combustion, I don't have to worry about switching places with anything or charges, nothing like that. All I'm going to write is the products, which are always the same, CO2 and H2O. Okay? So we've got the type, we wrote the products, now our job is to balance it. That's always going to be our last step. So I'm going to go through and say, okay, combustion, it helps to balance it alphabetically. So if I do carbon first, I'd put a 2 here. Hydrogen, there's 6 on the reactant side, so 2 on the product. So what times 2 is 6? So 3. All right, so oxygen now. I'm always going to do this one last. So I got to add up on the product side. 2 times 2, so there's 4 oxygen here, plus 3. So that's 7. Well, I can't put that over here. I can't get a 7 because times 2 is going to give me an even number. When this happens, go back to your first thing and double it. So I'm going to put a 2 here. And now fix everything else. I can do this. No. Alright, so let's try again. So I've got 4 carbons now. So I put a 4 here. Oops. Put it in the wrong spot. There we go. 4 here. There we go. Hydrogen. I have 12. 6 times 2. So I need 6 times 2 over here. So 12. So now look at the oxygen. 4 times 2 in my CO2 gives me 8. Plus 6 from my water. So that's 14. So what times 2 is 14? Well, 7 times 2 is 14. So there's my balanced reaction. So let's do another one. Number 2. I've got ammonia. This is one of the names you need to know. It's NH3. It's back in video 2. That's it. That's all I have. So this is decomposition. All it's going to do is break apart. So if I only have 2 elements in there, they're just going to separate into those elements. So I'm going to have nitrogen and hydrogen. Both of these are diatomic. Don't forget those 7. So I just have to balance this. I'll label it decomposition. So to balance this, let's see, nitrogen. I have 2 on the product side, so I need a 2 in front of my NH3. And then that's 6 hydrogens, so I need 2 times 3 to give me 6 hydrogens on the product side. So number 3, I've got ammonium carbonate. So it helps sometimes to write our facts out. Ammonium is NH4 plus 1, carbonate is CO3 minus 2. So I crisscross the charges, so I need 2 ammonium. So NH4 taken twice, CO3 plus magnesium sulfate. So Mg plus 2 sulfate is SO4 minus 2. So I get MgSO4. Alright, so let's see, I have a compound and a compound here. So this would be a double replacement reaction. So for this one, they're going to switch partners. So the positive is going to go with the opposite negative, just like the boy only goes with the girl at the dance. So ammonium is going to go with sulfate. So I've got my positive here is going to go with this negative. I don't have to write my ions again. I already have them. That's what's nice. But I need 2 ammoniums to balance out my sulfate. Negative 2. So NH4 taken twice, SO4 plus magnesium and carbonate plus 2 minus 2. So MgCO3. Remember the positive ion, the cation always goes first. And this one is already balanced. I like when that happens. So number 4, aluminum plus oxygen. So are either of these diatomic? Aluminum isn't, oxygen is. So here we have 2 elements. They can't switch partners. They can't replace anyone else. The only thing they could do is come together because they are element plus an element. It's synthesis. So how do they come together? Well, it depends on their charges. Aluminum is plus 3, oxygen's minus 2. So crisscross the charges, Al2O3. Okay, to balance this, I'm gonna put a 2 in front of the aluminum because I got 2 on the product side. Oh, well, my oxygens are 2 and 3. So I gotta multiply them both by something to get the same number. Well, 6 is the lowest number they both go into. So 2 times 3 is 6. 3 times 2 is 6. And that affected my aluminum, so I'm gonna come back here and change this to 4. Okay, let's do one more. Potassium, K, plus calcium chloride. So is K diatomic? Nope. All right, calcium is plus 2 chloride, so it's just chlorine, Cl minus 1. So CaCl2. All right, so here I have an element and a compound. So my K is going to come in and replace something over here. Potassium is plus 1. So it's going to replace the calcium. These 2 are going to switch spots because K can only go with Cl, positive with negative. So if they switch spots, K is going to go with Cl, plus 1 and minus 1, so my formula is KCl. Calcium gets kicked out. So now I just have to balance this with a single replacement. So to balance this, chlorine is what doesn't work out right now. I have 2 on the reactant side, so I put 2 here. And that changes my K, so I need a 2 in front of K. So that's how you write products. Make sure you're following those steps and balancing at the end.